Welcome to Acecert. Today we will be discussing practice exam questions for Google Professional Data Engineer Certification Exam. Question 1. Your company's on-premises. Apache Hadoop servers are approaching end of life, and IT has decided to migrate the cluster to Google Cloud Dataproc. A like-for-like migration of the cluster would require 50 TB of Google persistent disk per node. The CIO is concerned about the cost of using that much block storage. You want to minimize the storage cost of the migration. What should you do? A. Put the data into Google Cloud Storage. B. Use preemptible virtual machines, VMs, for the Cloud Dataproc cluster. C. Tune the Cloud Dataproc cluster so that there is just enough disk for all data. D. Migrate some of the cold data into Google Cloud Storage and keep only the hot data in persistent disk. The optimal solution is to store the data in Google Cloud Storage, GCS. Option A. Here's why. GCS is a cost-effective object storage service ideal for storing large datasets. Unlike persistent disk, which is block storage attached to VMs, GCS decouples storage from compute, leading to significant cost savings. Dataproc clusters can directly access data in GCS, allowing computation without needing large, expensive persistent disks on each node. This approach eliminates the need for 50 TB of disk space per node. Option B, using preemptible VMs, lowers compute costs but does not address the high storage costs. Option C, tuning disk space, doesn't fundamentally solve the issue of expensive block storage for large datasets. Option D, while helpful, doesn't go far enough. It is a partial implementation of Option A. GCS offers a scalable and durable storage solution with various tiers to further optimize costs for different data access frequencies. In short, leveraging GCS for data storage significantly reduces infrastructure expenses compared to using large amounts of persistent disk. Question 2. You want to use Google Stackdriver logging to monitor Google BigQuery usage. You need an instant notification to be sent to your monitoring tool when new data is appended to a certain table using an insert job, but you do not want to receive notifications for other tables. What should you do? A. Make a call to the Stackdriver API to list all logs and apply an advanced filter. B. In the Stackdriver logging admin interface, and enable a log sync export to BigQuery. C. In the Stackdriver logging admin interface, enable a log sync export to Google Cloud Pub Chart Sub, and subscribe to the topic from your monitoring tool. D. Using the Stackdriver API, create a project sync with advanced log filter to export to pub.sub and subscribe to the topic from your monitoring tool. The correct answer is D, because it leverages the appropriate Google Cloud tools for targeted log filtering and real-time notifications. Stackdriver, now Cloud Logging, provides powerful capabilities for managing and analyzing logs. To achieve the specific requirement of receiving notifications only for insert jobs into a particular BigQuery table, a project sync with an advanced log filter is needed. Here's why the other options are unsuitable. A. Listing all logs and then applying a filter on the client side is inefficient and not real-time. This approach is not suitable for instant notifications. B. Exporting all logs to BigQuery would incur unnecessary storage costs and introduce complexity when filtering for the specific table and insert jobs, which does not satisfy the requirement of instant notification to monitoring tools. C. While exporting to PubSub is a good first step, filtering and scoping log messages is needed via log sync with advanced filtering. Option D. By using the Cloud Logging API to create a project sync. Targeted filtering. It allows defining a specific filter, an advanced filter using the Cloud Logging query language, to isolate log entries related to BigQuery insert jobs on a designated table. This ensures no other table updates cause notifications, satisfying the question's requirement. Real-time export. The project sync can export filtered logs to Cloud Pub, Shach, Sub, a messaging service, in real time. Real-time notification. The monitoring tool can subscribe to the pub subtopic, allowing it to receive instant notifications whenever a matching log entry is generated. This approach combines the filtering capability of cloud logging syncs with the real-time notification ability of pub sub, providing an efficient and targeted solution. Question 3. Your company's customer and order databases are often under heavy load. This makes performing analytics against them difficult without harming operations. The databases are in a MySQL cluster, with nightly backups taken using MySQL dump. You want to perform analytics with minimal impact on operations. What should you do? A. Add a node to the MySQL cluster and build an OLAP cube there. B. Use an ETL tool to load the data from MySQL into Google BigQuery. C. Connect an on-premises Apache Hadoop cluster to MySQL and perform ETL. D. Mount the backups to Google Cloud SQL and then process the data using Google Cloud Dataproc. The optimal solution is to use an ETL tool to load data from MySQL into Google BigQuery. Option B. This approach addresses the core issue, performing analytics without impacting the operational MySQL database. BigQuery is a fully managed, serverless data warehouse designed for large-scale analytics. By moving data to BigQuery, you isolate analytical workloads from the transactional MySQL cluster, preventing performance degradation during periods of heavy load. ETL tools like Dataflow or Cloud Data Fusion can efficiently extract data from MySQL, transform it as needed, and load it into BigQuery. This process ensures that analytical queries run against a data warehouse optimized for such operations, rather than the operational database. Option A, adding a node to MySQL and building an OLAP cube there, would likely exacerbate the load issues as it still places analytical processing on the same infrastructure. Option C introduces unnecessary complexity by involving on-premises resources and a Hadoop cluster. Option D, mounting backups to Cloud SQL, adds latency with restoration and doesn't provide the analytical performance of BigQuery. Hence, B provides the best balance of scalability, performance, and operational safety, aligning with best practices for separating OLTP and OLAP workloads on cloud platforms. For a full list of practice questions, drop an email at acecert6@gmail.com. Thanks for watching.